Hi everyone, welcome to this series on the design, fabrication, and installation of a 5-post pavilion. This is Paul from North Dakota. I am about halfway done with this project actually. I decided to make a video because when I went looking for information I didn't find much. So I thought I would share with you the process I am going through as far as design, fabricating all the brackets, getting them finished, building the trusses. The unique thing about a 5-post pavilion is the front post has a 15-degree point, and it's all relative to your specific situation. We have a patio that is about 30 feet wide. It has a radial paver base, and the 5 posts fit well for us because we have a tree that we're working around. So with that, I'm going to show you some of the drawings that I've done as far as the layout, the footings, the bracketry, and we'll go from there. So this is one of the first drawings that I did. The outer profile represents the sunroom that we have on our house. It has a 512 pitch. This beam structure is the pavilion, and you'll see I'm attempting to match the same height and angle as the house. You'll also note that it's not as wide as the sunroom, and it's driven primarily by the length of this single piece right here. This is the 5th beam out in front that has a split lower post, but the other 3 trusses that you see in the intro on the model has a single piece. The longest piece I can get is 24 feet. So from that point to that point is 24 feet. Up appropriate amount to get a 512 pitch, which was, I'm using 22.5 degrees. That's how big it is. So from here to here is not as wide as the house. The next thing that I did was lay out the footings. I have 22 feet 6.5 from here to here, and that's driven by a couple things. You'll see right here that this 24-foot piece actually goes to here, but I didn't want the vertical support to be out over this skinny piece, so I think I moved it in 6 inches so that it is supporting more over the center of this joint area. So this is the footings. Originally I thought they were going to be small round, but they ended up being rectangular on the top. They're a little over 4 feet deep and about 30 inches in diameter. And that, like I said, there's 5 of them. This is pretty much 24 feet. They're 8 feet from here out, 12 feet from here up. Here it's 19.5 degrees from the center of this post to the center of this post, but the front truss on the building actually sits towards the front here, so it's 15 degrees. Did some load calculations based on what the city engineer requested, and it was asked that the footings be at least 16 inches in diameter, and we are, what did I say, 24. So this is the layout of the rectangular pad. It's rectangular form on top. The diameter of the footing is round, but we have a rectangular portion above ground. And the reason I went rectangular is the supports that hold the 6x6 beams sit nicer on a rectangular portion than they do the round portion, because the round portion, the brackets would hang slightly over on the corners, and I didn't like that look. So we made them rectangular. This one sits this direction and the other 4 are parallel in the east-west direction. This is a drawing that I did to help the concrete guys as far as measuring the forms from the outside or the inside of the form, but the outside of the concrete, and the angles so that we get it as accurate as we can. Being a 43-year aerospace engineer, I'm a little finicky. So everything on this project is within about 15 thousandths or a 32nd of an inch. That's my attempt anyway. So this is one of the first items that I did. It's the bracketry for the horizontal beam, the vertical, and the 245s that go out at an angle. I'm using 4x6 material purchased from Menards. The vertical pieces are 6x6. So this is a 4-inch piece of steel. Gives me 3/4 of an inch on each side. And you'll see that I drew in screws, and this is where the bolts go, and these are 2-inch screws that go in. So far I have not used these screws. I have been happy with the screwing joint, and at this point I don't think I'm going to put these in, but if I needed to, I have accommodated them to go in there. I tried to minimize the number of bolts in the bottom piece because I didn't want to take too much material away from this area here. So you'll see I have just in a straight line and then some of the screws that are on here. This is the top piece, the 22.5 angle, the vertical element. Again, you'll see my thought on screws, but not using that. One of the 45 and 22.5 pieces. The bottom with the 45 and then the 22.5. There's quite a number of these, and the thing about these is they have to be a front and a back as far as the way they're welded, because on the steel I chamfered it halfway through. I tack welded it on the back. I completely welded the front, clamped to a 5/16 inch thick steel plate, and then I ground the back. So there has to be a front and a back on the parts that are not symmetrical. This part, for example, is symmetrical. It's the same on the front as it is on the back. So I just had to make double of all of the same design on here. But on these, they're not symmetrical, so I had to make front and backs on that one, front and backs on that one, and front and backs on this one. This is the end of the lower beam. Here you'll see it's 24 feet to that point, and this is the 22.5 angle going up. This is just a rectangular plate to tie into the ends. And this is just a drawing of the base bracket and the rectangular concrete pad versus the round pad. You can see that they would have, the bracketry would have stuck out over the edge. I'm not a fan of that. So this gives me about 2 inches on each side here. I can move it a 1/4 inch or so and it's going to look still centered. So that is the basic principle of the design, starting with the space that you have. You've got to look at the lumber that you can get, and cost too, I suspect, but that's it.